Alright, so here we're starting at example 3, and we can see that example 3 is going to bring us a new challenge, because over here on the left side, instead of just the radical equaling a constant, the radical is equaling an expression. So we do have our radical isolated over here on the left, which seems like a great thing, which it is, but if we square both sides, which we are going to do, when we square this expression on the left, we have to truly square it. So we're going to come over here, and I'm going to write this out. X minus 2 times x minus 2. And so we have to expand that. So actually, to fill out our little note-taking guide the way they want us to, we need to write it like this. Okay, so I'm going to expand this on the left, and I'm going to square this. So x times x times negative 2, negative 2 times x, and negative 2 times negative 2. And I combine like terms, and that is now what goes here. X squared minus 4x plus 4. On the right side, the side that looks complicated, that's the easy side, because all we have to do, squaring to undo the square root sign, gives us x plus 10. So that's all nice and neat. And so now I've got to subtract x from both sides, and I've got to subtract 10 from both sides because I want to set it equal to 0. So I'm going to subtract x from here, subtract 10 from here, and I get x squared minus 5x minus 6. And since I'm solving an equation and this is a quadratic, oh gee, remember how I keep telling you nothing goes away in here? Yep, here we go, solving a quadratic. So I'm going to take x squared minus 5x minus 6, and I'm going to factor it. So this is the nice easy factoring because a is 1, so x squared is x times x. And then I'm thinking, what two numbers multiply to be negative 6 but add up to negative 5? Well, that would be negative 6 and positive 1. So here we go, x minus 6 and x plus 1. There's my factors. And of course now, to solve, we use the zero product property, and we set each factor equal to 0. And when I add 6 to both sides, I get 6. And when I subtract 1 from both sides, I get negative 1. Now, when we solve this kind of equation, where there is an expression on the opposite side from the radical, we have to check our solutions. It's not even an option because extraneous solutions can happen. So I'm going to check 6 over here. 6 minus 2, and this little sign here means, is it equal to? That's what this means. And so does 6 minus 2 equal the square root of 6 plus 10? Well, 6 minus 2 is 4, and 6 plus 10 is 16. So 4 does equal the square root of 16, which is 4. So that one checks out. Over here, I'm going to put negative 1 in for x, so I have negative 1 minus 2. Does it equal the square root of negative 1 plus 10? Well, negative 1 minus 2 is negative 3. And does it equal the square root of 9? Well, negative 3 does not equal 3. Does not equal. So the only actual solution is 6. The apparent solution of negative 1 is extraneous. So we would actually come up here in the problem and we would find where we found x equals negative 1, we would cross that out to indicate that is not truly a solution, it's an extraneous solution. Or you can write that it's extraneous. Okay, so now we still have another case. It's going to get even more complicated because now we have a case where we not only you have a radical on both sides, which really, if it's just a radical on both sides, that's not a big deal. You just square both sides. But look at this. It's a radical plus a constant on the left and a radical on the right. If we just square both, those radicals, yeah, it sounds easy, but we've got to deal with this 2. And if we subtract 2 from this side, it won't do us any good because we just have it on the other side. So what we have to do, get this, is we have to square the square root of x plus 6 plus 2. We have to square that, and the square root of 10 minus 3x. We have to square that. So look at, when you square one side of an equation, you have to square the other side. So we're squaring each side. So I'm going to take this part here over to our work area, and we're going to square this. So we have the square root of x plus 6 plus 2 times the square root of x plus 6 plus 2. And we're going to use our FOIL pattern to multiply this. So first, I take the square root of 6 times the square root of 6. Well, that's just taking that radical and squaring it. So that gives me just plain old x plus 6. So that's actually pretty nice. Okay, now I've got to take the square root of x plus 6 times 2. Well, they're both positive, so it's positive. So I have positive 2 square roots of x plus 6. Okay, now I've got to take this positive 2 and multiply it times the square root of x plus 6, which gives me positive 2 square roots of x plus 6. And then finally, I've got to take that 2 and multiply it times this 2, which gives me positive 4. Okay, this is great. This is some great algebra here. Now, we're going to take these two terms, which are like terms, and they're like terms because the radicand is the same, and the index is the same. And over here, I've got x plus 6. I'm just bringing this down. I'm combining these like terms to give me plus 4 radical x plus 6, and then plus 4. Okay, so now we have this. X plus 6 plus 4 radical x plus 6 plus 4 pardon me, equals the square on the other side, which is just the easy part, 10 minus 3x, because we squared that radical. So that was the friendly one. Okay, so now I'm going to come over here and I want to get this. You see how we still, even though we squared it, we still have a radical in this problem. So I'm going to get that radical by itself. And I'm going to start by, over here, I'm going to subtract x from both sides, which is going to give me, and I need to combine these like terms. I've got 6 and 4. So that's going to give me minus x. I've got 6 plus 4 is 10, plus 4 radical x plus 6, and equals 10. And x minus 3x is negative 4x. I'm just going to change that because I subtracted x. 3x minus 1x is negative 4x. Okay, now I'm going to subtract 10 from each side because I'm trying to get this radical by itself. So I subtract 10, and that gives me 4 radical x plus 6 equals negative 4x. And I still want to get that radical by itself, so now I have to divide both sides by 4. And this 4 divided by 4 is 1. So now I have the square root of x plus 6 equals negative 4 divided by 4 is negative 1. So I have negative 1x. Wow, you might want to go back and look at that for a minute. That was great. Okay, so now we're finally down to this simple little radical equation like we started with way back at the beginning of the first tape. So now I can just take both sides and square it, which gives me x plus 6 equals positive x squared. Okay, guess what? I have a quadratic, so I'm going to subtract x and subtract 6 from both sides. So I've got x squared minus x minus 6. I'm going to factor that. X squared is x times x. What multiplies to be negative 6 and adds up to negative 1 should be negative 3 and positive 2. Let's scroll down here. So now x minus 3 equals 0, or x plus 2 equals 0. Pardon me. So either x equals 3 or x equals negative 2. And we certainly do have to check those. So I have to go all the way back up to my original statement. Way up there. And I have to say the square root of 3 plus 6 plus 2 equals the square root of 10 minus 3 times 3. I'm just substituting 3 in for x. Pardon me. So the square root of 9 plus 2 equals the square root of 10 minus 9. The square root of 9 is 3, so 3 plus 2 equals 5. 10 minus 9 equals 1. The square root of 1 is 1. 5 does not equal 1. So therefore, 3 is this is an extraneous solution. Now we have to check negative 2. So once again, I'm just going to slot it into my original equation. So I've got the square root of negative 2 plus 6 plus 2 equals the square root of 10 minus 3 times negative 2, which gives me the square root of 4 plus 2 equals the square root of 10 plus 6. So the square root of 16 is 4 over here on the right. The square root of 4 is 2, and 2 plus 2 is 4. So this solution works. So the only solution is negative 2. The apparent solution of 3 is extraneous. Okay, so once again, I'm going to stop this recording and we'll continue on a new one. That was a lot of equation to look at. You might want to definitely pause this and go back or back up and look at that one again. That's the most complex we'll get.